Hey folks, welcome back. I'm Dan Meyer.
And I'm Bethany Lockhart Johnson. And welcome to episode 2 of the Math Teacher Lounge.
This episode, we are looking at technology. We are all awash in so much technology right now, whether you are virtual teaching or virtual learning or virtual living. Everyone's trying out new things, and we're so inspired to see so many people try out and pick up new skills over the summer in a hurry in order to teach better. But it's also raised loads of questions for us as well.
Sometimes I see technology show up in the classroom because it's a district mandate. They've purchased a program that they want teachers to try, or sometimes it's something that teachers have heard about from a conference and they're excited to bring it into the classroom. And sometimes it's just something that you as a teacher think might enhance your lesson. But no matter how technology ends up in the classroom, we want to think about what are its impacts and what does it do to our learning goals? What does it do to help our students with sense making? We decided we would ask some educators, some researchers, some people that we were just really interested in talking to, what does effective and ineffective technology use look like in the math classroom?
My answer is that technology is a tool, like a hammer or a saw. It can be used well, it could be used poorly, or simply abused. That is, it's not the technology per se, it's what we do with it to engage student brains.
Effective use of technology enhances already effective pedagogy. In the math classroom, that means the technology enhances mathematical representations. It fosters and creates spaces for student-led learning.
Ineffective use of technology in a math classroom reverts back to a more teacher-centered class, where the focus is on a procedural method. This means students are just watching a video with a set of steps and then replicating those same steps in a similar set of problems. There's a lack of engagement between the students, and their thought process is removed from the math classroom.
I love these answers here. They are so focused on the pedagogy and not the technology. It seems so important. I'm at an ed tech company, so in theory we're super pro tech and enthusiastic about technology, but really we're rather distrustful of it. For the one large reason that it decreases the reliability of the lesson. To tie it to the Wi-Fi, to tie it to a class set of devices working perfectly. So if we're going to use tech in math class, it had better support some pedagogical goals, and it had better really increase the value of the lesson, in my opinion.
I totally agree with you. And I think as a teacher who, when you're in the classroom and you're thinking of a million things, it's really easy to lose sight of those pedagogical goals when you're worried about, oh, am I going to be able to pull this program up? Or are students' iPads going to be able to access it? Or is it going to stream correctly, So I have definitely found myself in the position where I become so focused on the tech and the bells and whistles of, is this going to work properly? And do I know enough about the tech to be able to troubleshoot it, that I've definitely lost sight of those goals. And so I really appreciated their answers to be able to pull us back and say, tech is a tool, but it can't be about the tech. We can't lose sight about the actual math that we want the students to make sense of.
100%. Yeah, let's jump over to some other responses that also helped us understand some other aspects of technology in math class.
When using technology in the classroom, planning has to be intentional, and the technology that you are choosing needs to be purposeful. We should be asking ourselves, how will students access the technology? Is the use of tech supporting student learning and allowing them to think critically about math and have math conversations and collaborate?
I think the most effective use of technology in the math classroom are to find tools that facilitate communication. Tools that allow students to move the ideas from their brains out into the world so that others can play with and engage with them. And of course, this means tools that are accessible to students who have varying levels of English and technical language fluency. Students' language fluency and their mathematical thinking are not necessarily related, and so often this can be a barrier for students demonstrating their brilliance. So effective tools are tools that are accessible to all and help move ideas from your brain out into the real world.
That phrase, technical language fluency, right? We're not just thinking about students who are learning English or learning the language of the discipline for mathematics. We're also thinking about, is tech actually obscuring their access to it. So thinking about access more broadly, right? Access, are students actually going to have the devices, the material, the Wi-Fi to be able to access these tools? But then also access, even if they're on the device or on the program, are they going to be able to navigate it to be able to get into the math task? Or is the tech actually obscuring that and adding a layer where students are even further distanced from the mathematics?
I think I've almost always overestimated students' fluency with technology in a general sense. Like they've been called in the past digital natives, and there's this easy way that I have had, others have had, of just kind of glorifying the youth and their ability to use technology. But their uses are often like very specific to certain kinds of a niche set of uses on a niche set of devices. And then we put them in front of, a different kind of tablet or laptop and ask them to use this like sophisticated software or like a spreadsheet. And it's just easy to assume like, oh, like this student knows about that. And so what I'm seeing is their mathematical knowledge, when really their struggles do not relate to the math. It relates to the technology at times. That's just super interesting to me. Really appreciate that. We had a couple more clips that, again, just highlight so much about this issue for us. Have a look.
I think effective use of technology, allows students to tinker. And when I say tinker, when they ask those questions, they get the opportunity to explore the solution or explore a solution path or problem posing path for the question in which they ask. And so it provides feedback, and that feedback will serve as a mechanism for students to say, I understand it this way. If I try it differently in a different way, it might lead me down this pathway.
Is my use of technology going to increase curiosity and wonder in my students, or is it going to decrease it? Is it going to enrich the meaning of the ideas that I want my students to grasp, or is it going to obscure it? And underneath all these questions is the basic idea that technology is really an amplification tool. It can amplify good teaching, and it can amplify bad teaching. So if my lesson plan is well designed, then I can surely find some wonderful use of technology that's going to make that lesson plan really shine. But if my lesson plan is poorly designed, then no amount of technology is going to save it. And so that's the question. What is technology used in your classroom going to amplify?
These responses both really spoke to me and my experience with technology as a math teacher, where I got a digital projector in my classroom for the first time. This is a moment where they were not like commonplace in classrooms. And what I loved about them was not that I could, use them as another lecturing device or whatever, put my notes on them, though there was a bit of that. But what Barry and Sue say here, that it allowed us to ask and answer different, more interesting questions and to provoke student curiosity in ways that I couldn't with my whiteboard or with the overhead projector, that I'm able to bring in the world from outside the classroom. Examples of parabolas on a basketball being shot through the air, for instance, or a dilemma I had wondering what is the fastest grocery line. I'm able to bring in pictures and videos and provoke curiosity in students the way I never was able to without that device. These folks just really spoke to that for me.
And really, what are the goals of this? What are I want to get Sue's language exactly. Is my tech in the class going to increase curiosity? I love that. I love that idea. Is it going to enrich the meaning of the ideas or obscure it? So when we're thinking about tech, what are really giving ourselves the time and space with which as teachers we often don't have a lot of, but giving ourselves that time and space to be intentional and purposeful about our use of tech in the class.
We found these interviews all so inspiring, and we're grateful to our guests. And we'll be offering you folks some more comments from more people over the course of the next few weeks. I wanted to take all these ideas back to my team at Desmos and create a single activity, two versions of that same activity that illustrate these ideas put into practice around increasing curiosity and access to mathematics, creating connections And then also using it more in a way that strictly just evaluates students and tells them that they're right and wrong. So we're gonna look at that right now with Bethany. This is Bethany's first time in this activity. I'm so curious, Bethany, how you'll take this and what you'll think about it. So here's the activity: painting in 2 ways.
Why do I feel a little nervous?
Don't feel nervous. Don't feel nervous.
Okay, I'm a learner. Okay, ready?
You're a learner. Yeah. So this is a pretty standard ratio type task, one that you might see on a piece of paper, in a textbook, in a piece of online practice software. You've worked with students at K6 especially. I'm curious, like what is a common wrong answer to this kind of question? And then press try it. Tell us what you're doing and then press try it for us.
Brielle made a color using 5 cups of white paint and 7 cups of green paint. How many cups of green paint should you mix with 10 cups of white paint to make the same color? Okay, so if I'm looking at that first one, 5 cups of white paint, in that second mixture, there's 10 cups of white paint. So as a student, I might see that and say, oh, there were 5 cups of white paint added to get that second mixture. So I'm going to add 5 cups of green paint. So I can imagine a student doing that. So that would be 5 plus 7. So that would be 12 cups.
Makes tons of sense. Yeah.
12 cups of green paint. So I'm going to say, do I enter it here, right?
Yep.
And then push try it? Okay.
Yep.
Okay,
yeah, so that's wrong. And if you had typed in, if you had typed in 120 or a million or 1, a lot of online mathematics just gives you that red X is all it does, until you type in the correct answer. What are other ways to think about?
So do you get students just trying it until they don't get that X anymore?
That's what we see a lot of times. The students just they'll try it, kind of guessing and checking a little bit. So the technology here, it's been used. I think the visualization is, it's colorful. So there's that. But I don't feel my curiosity provoked. I don't feel connected to other students. I don't feel connected. The table is not connected to the contextual representation in ways that all of our guests were endorsing. Move to the next screen, would you, and try out that same answer on a different treatment here. This is where my team at Desmos, we try to be really thoughtful about what technology can do and tell learners about their very, very smart thinking. So same answer there, same question, same everything, and try it again here.
Okay, so if as a student I was thinking of that 5 cups were added, and I thought that meant that I needed to add 5 cups of green paint, and so then adding 5 to 7 would be 12. So if I thought that that's what I was meant to do, and I said try it. Ooh. Okay.
Yeah, and so just that, hold on to that feeling though.
Yeah.
Ooh, okay, you're not feeling maybe as evaluated by the technology with the red X, which is so common, but more hey, here's what you said, and let's just talk about it. That's what that means here, and I love that has provoked. I can see from you and hear from you okay, we're leaning in a little bit more. Let's see what just happened here.
I leaned in more.
Maybe just mentally, perhaps. Maybe I'm just inferring a little bit, but I like that effect on a learner. Then you're right, you're wrong. So where do you as a learner go from here?
Well, I think what was helpful about this is that I actually didn't even pause to think. I didn't take the response in as like you said, that evaluative sense. I didn't think, oh, I've failed this task. It was more, it did kind of provoke that curiosity. So if I made this lighter than the original, then it made me step back and think, oh, that must mean that in this new mixture, there's more white. So I didn't add enough green. And so it's going to have me go back to that original to look at the relationship between the cups of white paint and the cups of green paint. So for me as a student, it's helpful because it's having me pull back and kind of look at, well, it wasn't just about right or wrong. It was about what happened when I tried this version.
Right. So keep going. What's a different way that the white and green cups might relate to each other, if not through addition? What else is there on deck?
Yeah, so then do I push try again?
Sure.
So then does it reset it? Oh, there we go. Oh, look, and then it reset it. So as a student, then I might think, oh, well, 5 to 10, what's the relationship between the 5 cups in the original mixture and the 10 cups in that second mixture? Well, it's twice as much. So I wonder what happens if I say that there were twice as many green cups. And that also relates to the feedback I just got, because it was lighter. So then I would want this new mixture to be darker and have a little bit more green in it. So I'm going to up it. I'm going to double that 7 instead of just adding the 5. And I'm going to try 14.
Come on now.
Look at that.
Strong work.
I think the other thing I really like about this is the fact that it didn't just give me that check and say, yes, you were right. Good job. Right? It was like really about, I don't know, let's see what happens. And I feel like that's how I approach work with my students. If they're asking me, is this right or wrong? I'm like, well, let's try it. Let's see. And it's really putting that back on me as a student to think about, let's see what happens when I try this combination.
Yeah, the green check is mostly a formality here. It really could rely on you and relies on you to make sense of what you're seeing and say, do I like these 2 colors I made? In the same way that if you're mixing paint in life and you want to create the same shade, like there's no answer key for that beyond looking at the wall and making sure all the colors match each other. Head to the next screen, would you? There's one last thing that we tried to do here, which was to connect different students together. So we had this thing called a challenge creator, this class gallery. And what you see there is me. I'm a student in your class. And if we had other students in class, you'd see them there. And you could make your own challenge or try my challenge out that I left for you right there. Go ahead and click on Dan Meyer right there. Click on that thumbnail. And this right here is my favorite shade of blue right now. And
in real life, it is your favorite shade?
I love it. I made it out of 20 blue cups, 10 green cups, and 5 white cups. But I ran out of paint before I could paint my entire wall here. So it's up to you to create the right paint mixture. Give me some more paint here so I can finish up my paint job.
Oh, okay. So let's see. So I'm looking at that relationship again. And so this is my question. So is this you as a student? This is an invitation for you as a student for us now to collaborate together?
That's right. We are students in this class. Yep.
And I think this speaks to what a lot of the people were saying, right? About how do we think about this work at technology as allowing these opportunities of collaboration and connection. And I'm trying to see, can I match Dan's favorite blue? Okay, so I'm going to think about this relationship again. I want to try, let's see, I want to try 15 cups of green. And I'm going to try, can I try partial cups?
Let's find out. Looking sharp. That is a good looking wall. So you can press submit response there, and then on my screen, I get to see all of my classmates who have completed my challenge, and you see a record of all the challenges that you've created or completed, and you can create your own. And it's just wild to hear from students in a classroom when they are on this screen, how much more interested they are in solving each other's problems than they are in solving problems, the same problem created by a publisher or a teacher. That's pretty fun. And students are often yelling across the classroom at each other, like "That's impossible," or "This is too easy for me." That a little bit of trash talking sometimes. It's pretty fun. If you folks want to try this one out at home, you can head to teacher.desmos.com and search for paint in the menu bar. That's for you folks to try out and use. And for us, it was just a way for us to talk about like what is technology doing for the math, doing for Bethany, doing for me as the classmate or teacher. Thanks for that, Bethany.
Thank you. I love getting to try and think about math with you.
That's all from us today, but these questions about technology use will continue, obviously, for weeks, months, years to come, an entire career's worth of questions. So we'd love to hear from you folks. What makes for good and bad tech use in your classes? What is your favorite uses of technology in math class? Let us know.
You can email us, mathteacherlounge@gmail.com, or you can find us on Twitter @MTLShow. You can also find us on Facebook at our new Facebook group, Math Teacher Lounge. The Math Teacher Lounge on Facebook is a group that is designed especially for math educators like you. It's going to be a chance to continue conversations that we've started in these episodes. You can also suggest future content for our episodes, and you can check out additional content that didn't make it in these episodes, but we definitely want to share with you. We can't wait to see you there.